Yo, what's up guys? This is Lance and I'm Guzman from Math 2B, and today I'm going to discuss the measure of position of quartile and decile. In this topic, we will illustrate the following measure of position, the quartiles and deciles, and we will calculate. So what comes to your mind when you hear the word quartile? Quartile is the score points which divide the distribution into 4 equal parts. Q sub 1 is called the lower quartile, Q sub 2 is nothing but the median, and Q sub 3 is the upper quartile. Here's the formula on getting the quartile. Q sub k is equal to k divided by 4 multiplied by n, where n is the number of samples and k in what quartile, and divided by 4 because quartile divides the distribution into 4 equal parts. So we will find the median of the data values in quartiles. Example, let's find the Q sub 2, Q sub 3 for the dataset 15, 13, 6, 5, 12, 50, 22, and 18. The first thing we need to do is to arrange the dataset into ascending form. So let's find the median of Q sub 2. To find the median of Q sub 2, we need to identify first what is the second quartile. So 2 divided by 4 multiplied by 8 is equal to 4, and our fourth term is 13. Therefore, our Q sub 2 is 13. After that, let's find the difference between the two values where Q sub 2 is situated. So 13 plus 15 divided by 2 is equal to 14. Therefore, the median of our Q sub 2 is 14. Let's have another example. Let's find the median of Q sub 3. The first thing we need to do is to identify what is the third quartile so we can get the median of it. So 3 divided by 4 multiplied by 8 is equal to 6, and our sixth term is 18. Therefore, our third quartile is 18. Then let's find the difference between the two values where Q sub 3 is situated. So 18 plus 22 divided by 2 is equal to 20. Therefore, the median of our Q sub 3 is 20. So let's move on to the next topic guys, which is the decile. What comes to your mind when you hear the word decile? Decile is similar to quartile, but quartile sort the data into 4 equal parts, while decile sort the data into 10 equal parts. So the decile are the 9 points which divide the distribution into 10 equal parts. The formula of decile is like the quartile, but the denominator will become 10 because decile divides the distribution into 10 equal parts. So we will have d sub k is equal to k over 10 multiplied by n, where n is the total number of the samples and k in what quartile, and 10 because decile divide the distribution into 10 equal parts. So let's have an example so we can understand it more. So here we have the following given: 20, 30, 25, 23, 22, 32, and 36. The first thing we need to do is to arrange the data into ascending form. So example, we will find the fifth decile, or d sub 5. We will use the formula d sub k is equal to k over 10 multiplied by n. So we will have d sub 5 is equal to 5 over 10 multiplied by 7, because 7 is the total number of the samples. So 5 over 10 multiplied by 7 is equal to 3.5. And then we need to round up to get the fifth decile. So 3.5 will become 4, and our d sub 5 is equal to fourth term. And our fourth term in the dataset is 25. Therefore, our d sub 5 is equal to 25. Let's have another example. What if we want to identify what is the D sub 8 or 8 decile? Again, we will use the formula D sub 8 is equal to K over 10 multiplied by N. So we will have D sub 8 is equal to 8 over 10 multiplied by 7. And 8 divided by 10 multiplied by 7 is equal to 5.6. And we need to round up to get the decile. So 5.6 will become 6. So the D sub 8 is equal to the 6th term. Therefore, our D sub 8 is 32. What if we will find the median in decile? Example, let's find the median of D sub 5 of the following data: 20, 30, 25, 23, 22, 32, 36, and 18. Again, we will arrange the data in ascending form, and our n will be 8, because 8 is the total number of the samples. So since we will gonna find the D sub 5, we will have the formula D sub 5 is equal to 5 over 10 multiplied by n. So 5 over 10 multiplied by 8 is equal to 4. So our fourth term is 23. And then 23 plus 25 divided by 2 is equal to 24. Therefore, our D sub 5 is equal to 24. So if you want to try and solve, here are the following examples. In addition, the interquartile range or IQR is defined as the difference between Q sub 1 and Q sub 3, and it's the range of the middle 50% of the data. Example, if Q sub 1 is equal to 9 and Q sub 3 is equal to 20, so Q sub 3 minus Q sub 1 is equal to 20 minus 9 equals 11. So our interquartile range is 11. Let's move on to the next topic, which is the outlier. So let's define first what is the meaning of outlier. Outlier is an extremely high or low value in our data. We can identify an outlier if it's greater than Q3 plus 1.5 multiplied by interquartile range, or lower than Q1 minus 1.5 multiplied by interquartile range. So let's have an example and see how this works. Here we have the data 5, 6, 9, 9, 10, 11, 12, 12, 13, 14, 21, and 23. Here 23 is the highest value and 5 is the lowest. So the first thing we will do is to find the halfway point of the data. So here it is. And then we will find the median of the first and second half. So Q sub 1 is equal to 9 plus 9 divided by 2 is equal to 9. And Q sub 3 is equal to 13 plus 14 divided by 2 is equal to 13.5. So since we got the value of Q1 and Q3, we can now identify the interquartile range. We will end up subtracting these two values from one another. So Q3 minus Q1 is equal to 13.5 minus 9 is equal to 4.5. So the value of our interquartile range is 4.5. We can figure now what is the outliers. So to look for extremely high value, it must be larger than Q3. So 13.5 plus 1.5 multiplied by interquartile range, which is 4.5, is equal to 20.25. And to the low value, which is 9 minus 1.5 multiplied by interquartile range, which is 4.5, is equal to 2.25. So if I have points that larger than 20.5, they are an outlier. And if I have data points smaller than 2.25, those are also outlier. So looking at this data, we can say that 23 and 21 are larger than 20.25. So we can say 23 and 21 are outlier. And we don't have nothing less than 2.25. So in this data, we don't have lower outlier.